Okay, so the next thing, just to show you, I guess I don't want to beat this to death. I think it's helpful for more advanced programmers, but I want to show you this, maybe this visual. So let's just look at this. So this is inside the mind of Python. So I've created a list L1. It has the values L1, 2, and 3. So let's see what happens when I create it. You see the list L1 gets created, and in its memory, so this is where it has a storage, and this is where the ID was used to know where all these values are stored. So it has created L1 and it has stored it here. Now look at what happens when I assign L2 is equal to L1. Both L1 and L2 point to the same list. Very interesting, right? Python says lists are expensive. So if two lists are supposed to be the same, why don't they look at the same place? But now let's see what happens if I add a list to L1. Well, because L1 and L2 are looking at the same place, L2 also gets the extra element. You see, both the lists have 4 in it. So this is very, very, very important aspect of mutable collections. Usually when you make an assignment, for ordinary values, you get copies. But for things like lists, you don't get copies. They end up pointing at the same location. So be very, very careful when you're assigning lists, right? And if you need to copy stuff, we can cover that later. There's specific syntax. You should say L1.copy and so on, right? So let's not make copies at the moment. I don't think you need too many reasons to make copies. And I just gave you this example with ordinary variables. If you look at V1 is an ordinary variable, you say V1 equals V2, then they get their own copies. You see, V1 and V2 have their own copies of this integer. So if you change V2, only V2 changes. V1 is not affected, even though it was created from, V2 was created from V1 by the equal to operation. So the behavior of Python for assignment, for ordinary values and list type of values or collections is very different. Okay, and I only point it out because it's an important programming concept. Think about it for a while and be very careful when you're assigning anything other than basic values, right? When you're using this equal to operator, be very careful. Especially, so this is why mutation, you see all this complexity is because it's a mutable object. If you can't change the list, then it doesn't matter if they're both pointing at the same location. But if you can change the list, then you have to ask the question, do I intend for both I1 and I2 to get modified? Right? And that's why mutation makes us to think very carefully about what we need. Otherwise, we can have some, if you didn't intend, you want L1 to remember the list as its original state, and you say, I'm going to make a copy and modify it. If you write this program, it has a bug in it. Right? So you must explicitly make copies, etc. Okay. Again, for those who programmed before, you would have felt this pain. For those who are coming in new, just maybe a placeholder for something to watch.